In this video, we are going to talk about combinations of functions. So today we're going to talk about operations of functions and a little bit of composition of functions. And then tomorrow we'll talk more about composition of functions. So first we have this first little part where they give us a function and they want us to sketch. So this is a square root function that's shifted up 1. Now if we weren't sure, we could always make a table of values. So if I plug 1 in for x, square root of 1 is 1 plus 1 is 2. I would plug 4 in next because I know I want to plug in perfect squares, so that I would get 3. I guess I should have plugged in 0 first, maybe. So let's go back. So I plug in 0, I get 1. 1 I get 2. 4 I get 3. 9 I could plug in, and then I get 4. So I can see that these are all going in the positive direction, so I know it's going to look something like this. Actually, starting at 1. So my domain would be still 0 to infinity because the upshift of 1 does not affect the domain. Now this is a line. They would start at -5, have a slope of 3. And we know all linear functions have a domain of -infinity to infinity. All right, so now that we reviewed some functions, let's talk about if I have f of x plus g of x, that's really the same. It could also be written as f plus g of x. These are the same thing. So for example, if I was going to add f plus g, f was the square root of x plus 1, and then add that to g, which was 3x minus 5 from above. The only like terms I could combine are the 1 and the 5, so I ended up with the square root of x plus 3x minus 4. So if I'm going to state the domain for this equation, this combination, the only restriction I have is this square root, and I know that that means x has to be greater than or equal to 0. So that means my domain would just be 0 to infinity. The 3x and the minus 4 have no restrictions on my domain. The second one, if I'm subtracting functions, it could also be written as f minus g of x. So I would do square root of x plus 1 minus 3x minus 5. Notice in this case I use parentheses because I want to make sure I'm subtracting both, because I'll end up getting -3x plus 5. So I'll have square root of x minus 3x plus 6. Similarly, the only restriction I have is the square root of x. So my function would have to be greater than or equal to 0. This is multiplying f times g. So I'm going to do square root of x plus 1 times 3x minus 5, and I'm going to have to FOIL. So I'll get 3x square root of x minus 5 square root of x plus 3x minus 5. And that does not give me any like terms. Again, I have these square roots of x's, but those are my only restriction. So my domain, again, will still be 0 to infinity. In this last one, I'm dividing, so it's really f divided by g of x. So I'm going to put f on top, and I will put g on the bottom. Now on top here, this square root of x tells me that x has to be greater than or equal to 0. This bottom tells me that 3x minus 5 cannot equal 0. So if I solve that, that means x cannot equal 5/3. So it has to be greater than 0, and I also have an asymptote at 5/3. So I'm going to start at 0, go to 5/3, have that asymptote at 5/3, and then continue on to infinity. So when finding the domain of a combination of functions, we want to make sure we notice that the domain is the set of all real numbers common to both. So because the square root had a restriction, that's why it's 0 to infinity, versus the other one was -infinity to infinity. Quotient also has a lot of extra restrictions because we know that our denominator couldn't equal 0. So that added an extra layer of restrictions. All right, so then I'm going to do f plus g of 6. So what does this mean? This means I'm actually doing f of 6 plus g of 6. So f of 6 would equal the square root of 6 plus 3. which would equal the square root of 9, which would equal 3. G of 6 would equal 6 minus 2, which is the square root of 4, which is 2. So if I do 3 plus 2, my final answer would be 5. In this next problem, I'm doing f of x divided by g of x, and they want me to determine the domain. So f is on top, g is on the bottom. So the only restriction here, again, is this denominator. I know that x plus 2 cannot equal 0, so that means x cannot equal negative 2. So that's where my asymptote is going to be. So my domain otherwise is negative infinity to infinity, but I'm going to jump over that asymptote at negative 2. So my domain will be negative infinity to negative 2, union negative 2 to infinity. All right, now we're going to evaluate some functions using a graph. So again, this f plus g of 2 is really f of 2 plus g of 2. So first, if I'm going to find f of 2, I'm going to go to where x is 2 on the f function, so that would be right here, and my output is 0. Then I'm going to go to g of 2, and that's negative 1, so 0 plus negative 1 would be negative 1. So f of negative 1 minus g of negative 1, so f of negative 1 is right here, it's 3, minus g of negative 1 is right here, be negative 2. So minus negative 2, be careful, you're minusing a negative, so we're going to get positive 5. In this next one, we are doing g of 0 times f of 0. So g of 0 is right here at 0 times f of 0 is right here at 4. 0 times 4 would just give me 0. So this last one is g of negative 2 divided by f of negative 2. So g of negative 2 is right here, so it'd be negative 4. So negative 4 divided by f of negative 2, which is right here, is 0. So we actually can't divide by 0, so this is actually undefined. The last part of the notes here, we're going to talk about a composition of functions. So when we're doing a composition of functions, we are going to put one function inside of another. So sometimes it'll look like this, sometimes it'll look like this, but really what it's showing is that you are putting g inside of f. So for this first one, when it says f open circle g of 3, what this really means is you're going to plug 3 into g and then plug that answer into f. So another way to write it would be f of g of 3. So first I'm going to find g of 3. So g is right here. G of 3 would be 3 squared minus 5, so 9 minus 5, so it would be 4. So now g of 3 is going to get replaced with 4. So now I have to find f of 4. So I'm replacing g of 3 with the output, which is 4. So now f of 4, f is right here. Square root of 4 is 2. So my final answer would be 2. Let's apply this again here. So g of f of 1. So I'm going to find f of 1 first. Well, f of 1 is the square root of 1, which is just 1. So now I'm going to have g of 1, which if I plug 1 into g, 1 squared is 1, minus 5 is negative 4. This one's a little bit different, f and f, so that means we're just going to plug into f twice, but I'm going to find f of 16. So square root of 16 is 4, so this is going to become f of 4. and then f of 4 would give me 2, because I would take the square root of 2. So I took the answer from f of 16, and that was 4, and I plug it back into f to get 2. All right, this last one's a little bit tricky, but we're still going to work from the inside out. So first I'm going to find g of 4. G of 4 would be 4 squared minus 5, so 16 minus 5 would be 11. So I'm going to have f of 2 times 11, because I'm replacing g of 4 with 11, because that was what I found when I found g of 4. So now 2 times 11 is 22, so now I need to find f of 22. Well, 22 doesn't square root, so we're just going to leave it as the square root of 22. We can also do composition when it comes to tables. So same idea. First, I'm going to find g of 8. G of 8, so I'm going to go to where x is 8 and find the g, so that would be 4. Now I want to find f of 4, so I'm going to go to where x is 4, go to the f function, and actually my answer is just 4. All right, so if I have g of 5, I'm going to go to where x is 5 and go to my g function, so that would be 8. So I'm going to have f of 8. Now I go to where my x is 8, go to my f function, and my answer would be 9. For c, I'd find f of 5, so I'm going to go to where x is 5 and go to f, which is 0. So now I'm finding g of 0. So I go to where x is 0, I go to my g function, and the answer would be 9. All right, in D, f of 3, so I go to where x is 3, I go to my f function, the answer is 8. So now I'm finding g of 8. So again, I go to 8, go to g, and that answer would be 4. Find f of 4. So f of 4 is actually 4. So now I find f of 4 again, and the answer is just 4. In this last one, I'm going to find g of 1 first. Oops, I wanted it to be blue. G of 1, so go to where x is 1, go to the g function, I get 5. So then I'm finding g of 5. So go to where x is 5, go to g, and my answer is 8.